Now notice we have another energy level. Now let's look at something like, I don't know, sodium. Okay, now sodium, right? What's the atomic number of sodium? Sodium's atomic number is 11, right? So what do you have to do? We need 11 protons. Atomic number of protons go hand in hand. So we have 3 already here from our previous example of lithium. That's 4, 5, 6, okay, 7, 8, 9, 10. Okay, I need one more. So we got 11 protons, right? Now we need how many electrons if it's neutral? 11 protons, 11 electrons, nice and balanced, right, in terms of charge, right? So what we do, can we put the electrons randomly anywhere? No, we can't. Now we hold the 2n squared rule, right? And we agree that in energy level number 1, we hold 2 electrons maximum. Well, let's look at energy level number 2 in relation to the 2n squared rule. For energy level number 2, right? Okay, it's gonna hold 2 times 2 squared. 2 squared is 4, 2 times 4 is 8, okay? So that's very important. 8 electrons maximum go in the second energy level, all right? So since we have 11 electrons, right, we agree for sodium, Na, we can put 2 in the first, all righty? Then we can put 8 in the second, right? We can't put 9 there. Why not? Because 8's the maximum. If you put 9 electrons in the second energy level, major violation, right? So that extra electron, we're going to put it in the third energy level. So when you see 281, what does it mean? It simply means in energy level number 1, you got 2 electrons. In energy level number 2, you got 8 electrons. And in the third energy level, okay, you have 1 electron. I remember we made a note, right, that the outer shell is called a valence shell, and the outer electrons are called the valence electrons, right? But we'll talk about that more. Okay, so that's what 281 means. All right, so let's get some electrons. Energy level number 1, we have 1, 2. You're gonna put 2 there. In the second, 2 more there. Okay, 2 more there. Alrighty, and 2 more over here. So notice, right, we have 2, right, 2, 8 in the second, all right, 4 times 2 is 8 in the second energy level, and 1 more to make 11 goes in the third energy level. So here's the deal. This is normal filling. This is called ground state, okay? Everything's in the lowest energy level possible, right? But what happens as you come along and you zap sodium, right, with some energy? And let's say one of these guys in the second energy level, right, gets excited, gets promoted to a higher energy level. What's gonna happen? What are we gonna get? Let's promote one of them. Bam. Okay? So now, instead of having 281 in the normal ground state, you're gonna have 272. Okay? 2 in the first energy level, 7 in the second, and 1, 2 in the third. Okay? So once again, what you're gonna have? You're gonna have, let me see if you can see it, 2-7-2, this box right here. Now once again, how do you recognize excited state? You look at the filling. You see if the first energy level is filled, you see if the second one's filled, and so on. If you see an energy level not at its capacity, but you've moved to a higher energy level with electrons, you know that's an excited state. Sometimes they even ask you, is this configuration, is it possible? Well, you just simply look for electron, in terms of energy levels, you look to see if the electrons have gone over the capacity. For example, in the second energy level, if they have 9 or 10 electrons, major violation. Or in the first energy level, you have 3, 4, 5, or whatever, anything above 2, major violations. That's how you know an impossible configuration. But they mostly ask you ground state and excited state. To wrap it up, how do you recognize excited state? Anytime you have a lower energy level and it's not filled, but you've gone to a higher energy level. Now, how do you know the capacities? It's based on the 2n squared rule, okay? If you did energy level number 3, energy level number 3 would have a capacity of 3 squared, right? That's 9 times 2 would be 18, right? So normally what you see, you'll see the excited state questions dealing with energy levels number 1 and 2 mainly, okay? No problem. All right, guys, take care. It's a ground state, excited state. Ground state is normal, regular, lowest energy level possible filling. Excited state, once again, if you move to a higher energy level, but you haven't completely filled the lower, one of the lower ones, it's excited state, you're done. All right, guys, take care.